everyone, and welcome back. This is part 3 of our divisibility journey. In our first 2 videos we covered 1 through 7, and now today on our final leg we're going to cover divisibility by 8, 9, and 10. Alright, so let's go ahead and get started with divisibility by 8. So let me be up front here and tell you that when you're looking for divisibility by 8, you're less looking for whether something is divisible by 8 and more determining if something is flat out not divisible by 8. It's almost like a negation rule, okay? So let me give you an example. Let's go with the number 2048. Okay, so since 4 is a factor of 8, anything that is divisible by 8 also has to be divisible by 4. So the first thing we're going to do with divisibility by 8 is determine if it's divisible by 4. Okay, so if remember our rule from video number 1 on divisibility, we know that we need to look at the last 2 digits and determine if they are divisible by 4. So in this case we have 48. 48 is in fact divisible by 4. So we at least know that 2048 is divisible by 4. So now that we have that confirmed, we can move on to the next question, which is, are the last 3 digits as a number divisible by 8? And it's sort of like saying, okay, now it's worth putting it into your calculator or doing the long division to check. So I can look at these last 3 digits, and because we have a leading 0, it's still 48. And so we ask ourselves, is 48 divisible by 8? Yep, it is. And so we can therefore say that 2048 is divisible by 8. Okay? Again, this is a negation sort of rule, and so there may be numbers where you're like, dude, I might as well just put it in my calculator and that'll save time. True. But you're going to run into situations where you don't have a calculator. Say, certain portions of the SAT exam. So at least knowing how to determine whether it's worth spending your time on or moving on to the next problem is worth exploring. Okay, so let's do a second example. We're going to pick a number that's just a little bit bigger and a little bit more complicated, maybe not quite so intuitive. And we're going to go with 6,312. Okay, so again, step 1 is this number divisible by 4? And to determine that, we look at the last 2 digits, and that is 12. Okay, so 12 is divisible by 4, so we know this whole number is divisible by 4. So then we want to look at the last 3 digits and determine if this is divisible by 8. So is 312 divisible by 8? Okay, and so you can just pop that in your calculator or do a quick long division. So 312 divided by 8. 8 goes into 31 3 times. 3 times 8 is 24. 31 minus 24 is 7. Bring down the 2. 8 goes into 72 9 times. 9 times 8 is 72. There's no remainder, so we know that 312 is divisible by 8, so 6,312 is divisible by 8. Again, when you're dealing with a 4-digit number, if you're evaluating a 3-digit number, again, it seems kind of like, why don't I just put it on my calculator? And that's valid. But what if the number starts to get a little bit bigger? So let's go with another example. Let's go with 310,056. Okay, so this one is one that it's worth it for you to do the trick. Okay, you've got a 6-digit number. Okay, so at most you only have to carry out the last 3. So let's first check for divisibility by 4. The last 2 digits are 56. 56 is divisible by 4, so therefore we know this whole number is divisible by 4. So let's go to the last 3 digits for divisibility by 8. And again, 56 is also divisible by 8, so we know this entire 6-digit number is going to be divisible by 8. So that's divisibility by 8. It's observational, very much the way the divisibility by 4 rule works, but it's more of a, is it worth my time to keep investigating this number, or should I just move on to the 9s? All right, next up, let's cover divisibility by 9. All right, let's move on to the divisibility by 9. The divisibility rule for 9 is a lot like the divisibility rule for 3, in that we're going to add up the digits, and if the sum is divisible by 9, then we'll know that the whole number is divisible by 9. Let's start off with a pretty easy example that we already intuitively feel comfortable saying, oh yeah, that's divisible by 9. Let's start with 99. Okay? So 99. Most of us know that that's 9 times 11 and are comfortable saying that's divisible by 9. But let's use the trick to find out and verify how this works, okay? So we're going to add the digits. So we have 9 plus 9, and we get 18. 18 is divisible by 9, and so we know that 99 is divisible by 9. All right, let's move on to one that's less intuitive, a 3-digit number. Let's go with 405. Okay? Again, we're going to add up the digits and determine if they are divisible by 9. So we have 4 plus 5 equals 9. 9 is divisible by 9, and so we know that 405 is divisible by 9. Finally, let's do another larger number, one that, at least from my perspective, I wouldn't look at that and be, oh yeah, totally divisible by 9. So let's go with 8,883. All right. Again, we're going to add up the digits. So we have 8 plus 8 plus 8 plus 3 equals 27. 27 is divisible by 9, and therefore we can say that 8,883 is divisible by 9. So that's the divisibility rule for 9. It's a lot like divisibility by 3. We just add up the digits of the number, and if that sum is divisible by 9, then we know the whole number is divisible by 9. Last, not least, we're going to go over the divisibility by 10. All right, so we're going to wrap up our divisibility discussion with divisibility by 10. And we're going back to one of the easy ones, one of the intuitive ones, one of the ones you've been doing forever. And that is that a number that is divisible by 10, it ends in a 0. So again, this goes back to when you were counting by tens in early elementary school. 10, 20, 30, 40, and on and on and on. As long as that number ends in a 0, it's going to be divisible by 10. So that wraps up our divisibility journey. I hope you were with us for videos 1 and 2, which covered 1 through 7. If not, go back, check them out. They're full of great information. Today we covered 8, 9, and 10. If you'd like to get all of this information in a single, easy-to-read reference sheet, please check out the link to my website below. And be sure to leave me any comments or send me messages about other divisibility rules you'd like to see or other topics you'd like to see me cover. I love getting suggestions. Also, if there was one particular presentation style you enjoyed based on the last 3 videos, some of them I had everything up on the board to start with. Some of them I erased between and you didn't see that magical part. Which presentation style do you like best? I take that feedback and try to make it for better videos later. So thanks for joining me on our adventure in divisibility. I hope that it makes doing factoring problems or reducing fractions a little bit easier, that there's less guesswork, and that you can get through your homework and your exams faster. Join me next time. Thanks.